All right. Hello and welcome to the next episode of 3D30. If you're new to 3D30, this is Velo3D's LinkedIn Live and YouTube Live channel. We host this about every 2 weeks or so, and we dive into new topics all the time. With the trade show schedule, we do vary our timeline, so make sure to follow Velo3D on LinkedIn to get the latest show schedule. That's the best way to stay informed. You know, if you've seen the cards behind me here, one of them, there it is, that side. Okay. Then you'll notice I was in the Army for about 4 years. And so this session, I'm really excited about that. We're going to talk about AM and Department of Defense. And so combining two of, one of my past careers and my current career together to see what we find out here. And, one of the interesting things, if you look at AM and trying to get it to work, to support warfighter readiness, you've got two sides of the coin. One is development. And so you have a nice controlled printer. It's in a headquarters office. You've got PhDs running it day to day, and that's fine. We are doing that. But then the other side of the coin is deployed. So let's say you want to print spare parts, and that's definitely a value proposition that we see AM serving. But that's not as easy. And we're going to find out today some of the challenges to get the same quality, geometric accuracy, material properties in the field that, running that system with a forward deployed soldier that you can get at headquarters with a PhD running the system. That's kind of the challenge that we're going to put out here today. And if you put yourself in the shoes of those soldiers, you can see why that's going to be a challenge. You don't want these parts to not work. You want these parts to be the exact same. So, we're going to change the landscape a little bit with Velo3D's technologies. One of the things that Velo3D brings to the table is what we call this golden print file. And the idea of a golden print file is that once you slice the file, once you create the two-dimensional directions for the printer to execute on a three-dimensional object, you can now send that file digitally to any Sapphire printer in the world, calibrate that printer, and that printer is going to behave the exact same as the printer in headquarters. And that is unique in the industry. That's one of the differentiators for Velo3D. And that's going to be very powerful in enabling this kind of concept going forward. To help us learn more about this movement, we have brought on the Director of Additive Manufacturing for the Hartech Group. And this is Gary Burdell. I'm going to bring him in. There we go. Hey, Gary, how are you doing today?
Hey, Mike, how are you? Thanks for having me on 3D and 30.
Great to see you. And for everyone joining, this is a live session, so please feel free to ask questions at any time. We love to field your questions. We want to hear from you as we go through the show. So, Gary, can you give us a little bit of a background about yourself?
Sure. I've been involved in the 3D printing industry, the AM technologies, since the very beginning, probably around 23 years ago. In the early inception of SLA and SLS, working for a company called Paramount Industries. And we, when the technology came out, it wasn't good. There are a lot of challenges. We've come a tremendous way in this industry in the last 23 years since we started using it. But while working at Paramount, we did a lot of work with aerospace defense companies. We did some work for the Air Force Research Lab with B-basis analysis and high temperature peak and PEC materials. Then we transitioned into the metals at the company, and we always maintained a traditional base of CNC machining, injection molding, casting technologies, sub-assemblies, assemblies, kittings, inspections. And the owner of the company sold to 3D Systems, and then at that point I transitioned out and started selling to the federal government. And I really enjoy going out to the different bases and seeing the different challenges that each base has, and certainly all of the cool equipment that's out there.
And that's with Hartech that you're getting to see that, right?
Correct.
And can you give us a little bit about what Hartech does? What do you specialize in there?
Yeah, so Hartech works exclusively with the federal government. We are a woman-owned small business, so a small business and woman-owned gives us purchasing power a lot of times. There'll be solicitations coming out that are 100% small business set aside. That helps us win contracts. We're a complete turnkey operation, and what that means is we will do the rigging, concrete work, electrical work, the building outfitting, whatever's required on a base to install a piece of equipment. An example of that, we just finished a large gantry CNC mill being installed at Tinker Air Force Base.
Mhm.
We did all of the concrete work, which involves cutting existing concrete, removing it, pouring a pit, new slabs, getting everything signed off by the base, the administrator. We ran a new power panel to the machine. We had the riggers there when that machine arrived. It arrived in 14 tractor trailer loads of equipment. So we had outdoor staging, we had indoor staging. We assembled the entire piece of equipment. We oversaw the operation. We oversaw the training, both for the operator and the maintenance people, and actually turned over the keys last week. So when we say turnkey, it's turnkey. We turn the keys over and they are making parts. So that really separates us from somebody just selling a piece of equipment and washing their hands and walking away from it. And the other side of the business with Hartech is the procurement side of the business. It can be really tough navigating through the government, the federal procurement process. We've done a great job over the last 13 years of getting some vehicles in place that help out with the procurement end of things, like a Mac IDIQ contract, which is multiple award contract with indefinite delivery and indefinite quantity. That covers 14 major bases, and it's up to 248 million over 5 years. We also have BPA, which is a blanket purchase agreement for several bases, and we're a GSA contract holder. So Hartech Group has been handling traditional machines for 13 years, meaning CNC machines, water jets, pipe benders, and so forth. And I was brought on to head up the AM division about 8 months ago.
And for that AM division, what type of parts or applications do you see that are in demand for DoD?
Yeah, well, just if you just look at the Air Force, they've got aircraft that are flying. They're going to be flying 60 years past when they were supposed to have been retired. You can't get parts anymore. They put parts up on the procurement list. There's a 300 or 900-day waiting list, and they'll put it up again a year later, and it's still a 300-day waiting list. So they're not available, and we have to keep these aircraft flying. So we can either get a electronic package from the source, which could be Boeing or Lockheed. A lot of times there are no 3D prints, 3D drawings, electronic files. So we have to, the DoD has to laser scan that part, reverse engineer it, and then grow it and get it onto the aircraft. But there are some hurdles to cross to get that part approved and get it onto an aircraft. Certainly if it's a flight-worthy part.
And you've been working with us at Velo3D. Where do you see Velo3D fitting in specifically to reproduce these parts?
Yeah, great question. I interviewed quite a few companies when I came on board to see which partners we wanted to take on with Hartech Group. I settled on Velo3D for the powder bed because they have the most advanced machine on the market right now. The machine was designed to make very complicated parts reliably, efficiently, and repeatably. I think when Benny started early days of getting design parameters for this machine, he went to the rocket industry and asked them, what percentage of parts are you making that are 3D printed? I think the percentage might have been like 5%. They said, well, if you didn't have the design issues of design for additive manufacturing, would you manufacture more parts additively? And I think the percentage went up to like 65 or 75%. It was huge. So the whole design around this machine was designed to make parts the way they were designed to make the best part for the best application, not limiting to design for additive manufacturing.
So let's kind of walk through this from, we mentioned kind of the soldiers for deployed. Let's say we have a part, this is kind of this ramjet example. You mentioned copper, so this could be some kind of thruster. So you have a part, you're out in the field. What's the process that you're going to go through to get that part out there?
So what the DoD is looking at right now is to have parts made near theater, not in theater. So what they'll do is, one of the arsenals here in the States may have a build packet, which means they'll build that particular ramjet engine part that you had up on the screen. They'll build it here, they'll validate it, make sure that's exactly what they want to put on that piece of equipment. or artillery shell, whatever it is. And then they'll send that build packet electronically and encrypted near theater to build it. Now, the people here in the States have been running 3D printing technologies for years, so they're very up to speed on the technology, know how to run it. A lot of cases over there in near theater, you're going to have a foot soldier that's dropping an electronic file in a machine, loading powder in and hitting the button. So with Velo 3D, with that whole process in the package, with the flow software that we have and the auto calibrating, you can be sure that that part is going to be built the same near theater as it is here in the arsenal on the base.
And what's included in that file? Are you just sending the CAD file over, or the design, or are there other things that are included in that?
So would it be the whole slicing file complete? So whatever's validated over here, you'd send that exact encrypted file over there. And because we have the one-touch laser calibration and also the lasers being calibrated as we're building, you can be assured that the parts are being built the same there as they are here. What's critical about that is if you have a part in our large machine that's 600 millimeters in diameter and going up to a meter tall, you've got thousands and thousands of layers, and those 8 lasers have to be uniting exactly perfect on every layer to make a perfect part. And that's what Velo 3D offers in here. Another thing, and that's all taken care of with the Flow print prep software package.
Yeah, we got this is the flow environment that you're talking about. So this is going to add in some additional functionality. You've got that. We mentioned this PhD running the system at headquarters. He's going to add some information to this file. Can you talk about that a little bit?
Yeah, so you could add the information in as far as the material that's going in, the layer thicknesses, support structure, whatever is required to build that part would all be in there. So it's really pretty simple for the guy on the other end to take that file, load it into the Velo 3D system over there, and then make sure you have powder in the machine and you're up and running. So that's and it's going to be repeatable, better than any machine out there in industry currently. So Velo 3D certainly has the most advanced process out there to date.
So you've got now we sent the file, we got the soldier on the ground. What are they responsible for?
So you'll, like I mentioned earlier, you'll be putting the powder in the machine, make sure the build plate is in, you're ready to build it. And then when the build is complete, you'll have to raise the build up, vacuum that loose powder that's out, that goes back into the machine to be reprocessed and reused. Then you'll take that part out of the build chamber on the plate, and you may have to do a heat treatment. You may have to wire EDM it off the plate. They may have secondary operations like CNC machining, let's say, for a specific tight tolerance area on that part. All of those machines are there near theater. So if you need a CNC operator machine, it's there. That can be taken care of over there in the theater, near theater arrangement.
Okay, interesting. So they can do all the post-processing for these parts. That's actually, that functionality is there as well.
Right, absolutely. Okay. And it's going to be required. You're going to need it over there, just like you would here.
Is this a model that's currently in use, or are we talking about something that's coming like in the next Top Gun movie? This is the way they're going to fix the jet or something.
It's in process with polymer machines. There are polymer machines that are in Connex boxes, which are very near theater. And a Connex box is basically something that's self-contained. So everything inside that Connex box is what you need to print. The Navy actually put a Connex box with a metal wire-fed system on one of their ships a couple of weeks ago. So it's a requirement for them. There are printers in near theater that are printing polymer parts. They've been looking at metal for a long time. And powder bed is one of the challenges because of the powder, because of the complexity of the system. But as long as you've got a temperature, humidity controlled environment over there, and a lot of these places are large, big hangars that you don't have that, you'd have to build a self-contained room for that piece of equipment. Not insurmountable. They do it all the time. So it's definitely something they're looking at, they're looking to do. As far as I know, and I've been asking this question, there isn't any powder bed system, metal powder bed system near theater yet. But looking to get that in very soon.
And we kind of mentioned this transferability challenge. What do you see that makes that process not transferable? Like, why isn't this just a normal thing anybody could do?
Yeah, when you look at a CNC machining operation, you send a build file over, and it's, as long as you got the cutters set properly, you've been doing this for, CNCing for 30 years, you hit the go button and you should get the same part. It's not quite the same with powder bed. What sets Velo 3D apart is the one-touch calibration. So you'll calibrate the lasers and the machine before you start, and it's auto-calibrating as you're building. And again, if you're building a large part, you're building thousands of layers on that part. And that's really what sets us apart from some of the other equipment manufacturers out there. There's certain equipment that's qualified to build production parts in the medical industry, in the aerospace industry. If you move that piece of equipment, you have to go through a whole new qualification process to be able to build that part again. Not the case with Velo 3D. We can have a part here, build it in one of the arsenals here, validate it, send that build packet encrypted over to another place in the US or overseas, and it's going to build that same part. So really a big differentiator, along with other things from Velo 3D that we have to offer.
You mentioned kind of these large parts. I did want to show this one. This is a little bit of a sneak peek. This is a impeller, obviously, if you're used to seeing this design. The build plate for scale is 600 millimeters wide. So this is all in our Sapphire XC. This is one of the parts that we printed. We're going to have this part at IMTS. One of the cool things about this part is it was printed with 4 different lasers. And Gary, kind of to mention your point, good luck finding the stitch lines, because those calibration routines are done every layer, and the stitch lines are just about impossible to find.
Right, and that was a factor. It still is a factor with some of the other manufacturers that have a knit line or a crossover knit line. There have been issues with that in the past, and Velo's been able to eliminate those issues as well. And I forgot to mention earlier, Mike, the contactless recoding system that we have is another great feature that Velo 3D has incorporated and nobody else has in the industry. So when you melt a layer of powder, that build chamber drops down a small increment, but there could be a splatter that's sticking up that the other systems out there have a blade that comes across, or a roller. If that blade contacts that splatter, it'll either damage the blade, or it'll damage the part, or it'll just stop the build altogether. With the Velo 3D system, with the contactless recoding system, you don't have to worry about that, because we never contact that part. So, and when you're building thousands of layers to build a part, everything comes into play, and that's one of the critical features as well that the foot soldier out there near theater doesn't have to worry about.
Awesome. So, just a reminder, we're doing a live show right now. If anyone has any questions for Gary, we're talking about DoD and defense applications. We're talking about the challenge of deploying metal additive manufacturing as a method to print spare parts in the field. These are all, tremendous challenges that it looks like we've got some good solutions for in the coming years. Yes. So if you have any questions, or you want to ask more about this, please send your questions in. We'll be happy to take them. So, if we look at, you kind of mentioned the repeatability of the system, and the ability to have the quality there with the no stitch lines and non-contact recoder. One of the things we look at are kind of these advanced geometries. Are you seeing that there's a desire to go and push the envelope with new geometry? Or is it more about spare parts?
It's both. Depends which part of the DoD you're looking at. There's DoD for weapons and arsenals that are developing new products that are certainly pushing the envelope. That Velo 3D can help, because we can build with minimal to no support structure. We can get down to a 0-degree angle depending on the material and the part we're printing, which have been challenges before. And then the other side of that coin is just building a replacement part. So if you've got a big piece of a Humvee that's broken out in theater, it may be a CNC or a cast part, but you can't get it. Or it's going to take you 2 to 3 weeks to fly that part from here over to theater, and then you still got to repair it. So if you've got a data file you can send that data file over there, have it printed, and it may not be in exactly the same material that that part was built in or cast in originally, but it's going to work. And at least will get the Humvee back out of danger or back up and running. So replacement parts are one thing. A lot of this stuff was designed many, many years ago. Some of the helicopters and aircraft were designed back in the 60s with materials and processes that were available back then. You can look at a titanium 3D printed part now, which could be stronger, lighter, but it's not made out of the same material or the same process. So somebody's got to be able to say, okay, that part's going to work. We're going to sign off on it, put it on the aircraft or the vehicle, and let's get it up and running. And there's a lot of examples out there in the military doing that now, where they take that challenge, and certainly if it's not critical to the operation of the vehicle, it's not going to harm anybody. It's pretty easy to sign off on that. If it's a flight critical part, then there's a lot more levels of sign off and authority that need to go through to be able to get that part on.
Yeah, I remember running some motor pools, and we used to have to generate a report for any of our equipment that was down for more than 30 days. And that was like highlighted to the generals. And so as an executive officer, an XO, running one of these motor pools or running, one of these bases with equipment, you need to get these things up within a certain amount of timeline. And one of the cool things with additive is, you can print these parts fairly quickly. You can do the post-processing as required, but 30 days is very doable for just about any mission critical metal part that you need. So now, you've gone from trying to explain things at a very high level to somebody you don't have to explain things to being able to, green to green everything in your fleet, basically. It's really powerful.
Yes. And 30 days is a lifetime out in theater. So if you got a piece of equipment that's down out there, you want to get it back up and running much quicker. So and it eliminates a lot of the spare parts that you need, which is one of the reasons the Navy is looking at 3D printing metal parts on a ship, because they carry a tremendous amount of spare parts on a ship, but you never know what's going to break. And it could take weeks to fly a part out to a ship, and if you can find it. So if you've got a data file, you print the part, you get it back up and running, and keep going. Same within theater.
No, and your point about you never know when things are going to break. I mean, you've got parts staged throughout the entire chain. You've got parts that'll be in a headquarters. You've got parts that'll be in a local facility. You've got parts that'll be on base. You've got parts that'll actually be in the motor pool. All throughout that, you've got parts scattered and littered everywhere, trying to predict what's going to break in a greater degree of frequency, and where it should be for distribution. And it's just really complicated to try and get that system to work versus being able to just locally say, hey, I need this part, and then have it basically run.
And especially when you're in theater, you never know what's going to break, right? And if you're being shot at, or if there's damage coming to your vehicle because of enemy fire, whatever the case is, you may break things that have never broken in the past. And we don't even.
Well, just driving them more, like
just driving them more. Yeah.
You sit in the motor pool all week long and don't go anywhere, and now you're being driven all the time. The more miles you put on a vehicle, the more things you're going to have to replace. Right. So,
and if you're being shot at, you're driving it fast to get out of there.
Yeah, thank goodness never had to deal with that. I just had to count weapons. That's all I had to do. But that was good. So we kind of touched on metals a little bit, and I think it's interesting to look at, when you talk about these alloys, there are some differences. If you've got like a billet, that might be a different material than what is printable. And we're looking at, printable materials. You have to be able to weld that material. So there are certain requirements for the metal themselves. What type of alloys do you see are in demand for DoD?
There are a lot of them in demand. Certainly aluminums, stainless steels, Inconels, copper. And you touched on it in the beginning here, was that the part may have been designed for a different process. Like there's a cast housing on a helicopter where the rotors go, and it's a casting, and it's filled with porosity. When you CT scan that part, it's full of porosity. And you look at a 3D metal printed part, if there's one tiny little speck that's not 100% perfect, it might get rejected. So I think part of it is we have a wide variety of materials that we can print in, but it's going to be the application specific and being able to get signed off on the other end. We can build parts better than they built them in the past. We can hip them if we need to get rid of any tiny little speck that's in there. But yeah, there's quite a few metals out there that are in demand, and we're never going to match everything that's out there on these different vehicles and the way they were designed, especially 40, 50 years ago. Now there is a push to have new vehicles designed with 3D additive in mind, because they know that we can repair them quicker and have more access to spare parts than they have in the past. So there's a push from the DoD, if they're ordering a new aircraft Humvee from the supplier, they want the package and they want 3D data if possible.
Okay, that's actually really interesting. I know from our experience at Velo 3D, there are materials that are chosen because of cost, and that's been the main driver a lot of times in picking one material over another. When you look at a printed part, the actual cost of the raw material ends up being a smaller percentage of the finished good. So, moving from steel to Inconel, for example, that may be a viable alternative that allows them to have a higher performing product, but also something that is more 3D printable. So there's something to think about, the flexibility to go in and make modifications like that.
Yeah, and I think if you got a part that's broken out in theater, if it's printed, it was cast in steel and you can print it in titanium and it's stronger and lighter, I don't think there's going to be an issue, especially if it's not critical to the function of that vehicle. Let's print this thing, let's get it back on and get it back in theater. So especially it's going to be stronger and lighter, titanium versus a cast metal part. There's no question it's going to be better.
Yep. I mean, these things are going into rocket ships every day. So, we've kind of got it down to a science at this point where it's pretty predictable, pretty well-established manufacturing process.
Right.
Awesome. So, one of the things that we haven't really talked on that I do want to ask is with US or with Velo 3D being a US-based company, the design is out of California, the manufacturing is out of California. Has that been a factor in your discussions with DoD?
Yeah, it's a good point. There are a lot of solicitations that come out and they have the Made in America clause in there. And other manufacturers sort of get around that by saying, well, they have a U.S. sales force here, so it's a U.S. company, but it's not manufactured in the U.S. So it's a good feature for us to have, Velo 3D, because it is made in the U.S. and we can check that box off that it's, that the clause for made in the USA here is good. So yeah, I'm happy to see it, and DoD is going to be happy with it as well.
Awesome. Well, we are kind of getting close to time. I do want to advertise one more time. If you have questions and you want to ask Gary anything, you got about a minute and a half to get those questions in. So, hurry up and get those in. But Gary, what are your final thoughts on the conversation, or where do you think things are going in the future?
Well, final thoughts, I'm happy to have Velo 3D as a partner with Hartech Group as we go out there and start getting some more of these machines placed in industry. I think you're going to see a bigger, more widely accepted acceptance of metal 3D printed parts. I was on several bases in the last few weeks, and all of them are getting some new equipment, powder bed fusion equipment, different metal printing technologies that are out there, a hybrid technology. So it's being accepted, it's being adopted. The industry knows, DoD knows that it's part of the future, especially when they're asking for the printed packages up front when they're ordering a new piece of material. So, just happy to have Velo 3D as part of Hartech's group of partners, machine partners here to move forward with.
Yeah, no, we're excited to partner with you. Lots of great insight today. Thank you for your time. I learned a ton. I think it's amazing where this is going. Can't wait to see, 3 years from now. It seems like a long time. I bet a lot's going to happen in that amount of time.
Lot is going to happen. It's changing rapidly. It's being adopted quickly. So I'm looking forward to the future as well. So thanks, Mike.
Yeah. One last thing though, if people wanted to get in touch with you, maybe they wanted to ask you a question directly, what's the best way to do that?
Yeah, best way is to hit me up on email. I'll be happy to get back to anybody. email is gburdell@hartechgroup.com. It's up on the screen now. So please hit me up with any questions. Be happy to discuss it further.
Great. And everybody, thanks for joining us today. I hope you learned something. Hope you learned a lot, actually. Make sure you follow Velo 3D to get the latest show schedule. We've got a lot of things planned until the end of the year. A lot of exciting topics. And again, the schedule tends to be a little bit flexible with these trade show schedules. So make sure to stay tuned and follow us for more.
Great. Thank you.